Thanks so much for coming so early in the morning. My own team on here, so they're like, don't wait for us. So we'll see. They're probably having breakfast. But so I'm Philip. I'm from Octafin or Octafin Digital. We're a digital agency doing lots of Drupal stuff. I've been going to DrupalCon since sort of 2011. I've been using Drupal since like Drupal 6. But we specialize in wildlife conservation. So we've got a very niche thing that we work on. We do some stuff with the arts, but sort of 80-90% of our work is in the wildlife conservation sector. So we do lots of interactive maps, lots of building big databases, that sort of thing. So it is a sort of tech for good thing. I think one of my key aims in this presentation, one is get lots of mapping and GIS stuff over to you, but also to make you aware that there's a lot of bad tech going on in the world, lots of immoral stuff, really awful tech companies, and even just looking around who agencies that are here work with, it's not great always. So there is amazing tech for good stuff out there, and you can get paid for it. We're quite successful, so it's not just working for big corporates. You can do really good stuff that actually helps the planet. So what I'm going to do is go through some basic sort of GIS stuff. So GIS is sort of the tech term for maps, basically. So if someone says, I do GIS, it's just geospatial information, whatever, but it's actually maps. So just don't get scared by those sort of technical terms. I'm going to go through some basic stuff about how maps work, the type of things you can do with maps, mention Drupal here and there, like where we've used it, where it's a bad idea to use it, where it's a good idea to use it, and sort of do a showcase of some projects and things towards the end. So I'll try and cover as much as possible towards the start of just general stuff about maps, how they work, how you do that sort of thing. And then towards the end is where I'll also show some demos of some of the front end things you can do. So the start will be all about sort of getting map data ready, what you can do with map data, how you process some of it, that sort of thing. And then the later one, which we might run out of time on, we'll see how it goes, we will do stuff about sort of covering where you can use maps, how you can do fun interactive things with them. There is almost no limit to what you can do on the front end, so I'm going to try and go through as much as possible, but the lesson is mainly you can pretty much do everything with maps. So yeah, going forward. So that's us. We work with lots of these wonderful organizations, as I said, in the wildlife conservation sector. So one of my first mapping projects, probably about 12 years ago, after I sort of got excited about maps, actually at DrupalCon London, was a map of Thames marine mammals. So this is sort of sightings of marine mammals in the Thames, which is sort of seals, dolphins, porpoises, that sort of thing. So we did this for ZSL, who are the sort of parent organization of ZSL London Zoo, which you might know of. So yeah, I was working there at the time, but then continued to collaborate on it. So this was a wonderful little project. This is all data from this year. So this project launched a good 12 years ago, and we haven't touched the code, and it's still there being used every single year. So some lessons learned from doing this. This was just reading from a form where people can submit things. PHP form puts GIS coordinates in, so longitude, latitude when clicking on a point on the map, and puts things on there. So what we sort of learned from this, or what I learned from this, is maps are a beautiful, clear way of showing information. But another lesson is data visualizations can lie to you. Now, we probably see this a lot in sort of politics and other things, but if you look at this map, it looks like all the seals live in London. Now, this is not true. There's just more people in London, therefore there's more sightings of the same seal in London when it goes through. So there's much more around here, but here you've got a lot of sightings. So don't necessarily trust the data you see on these things, because you have to understand sort of the underlying data, what the story's about, and how it could be skewed. Another thing you might see here is people have clicked off the map. So there is some sort of spam prevention. There's something there, but what we didn't do is cap it to an area of water. So if I were to build this again, then or help with it, if we get any support to do it, then I would probably stop seals or dolphins appearing in the middle of the countryside. So there's a few there tend to not be spam entries. They tend to be joke entries where people think it's funny to say, "Oh, I saw a seal up a lamppost," which is harder spam to deal with because it's actual humans. The other thing I learned from doing this was the last minute feature is often the best bit that you do of something like this. So we were very, very close to launch, and we had these wonderful little descriptions of what sort of happened, what someone saw when they saw the seal. And I thought, hold on, let's just use pop-ups and maybe animate them to just jump around while you're looking at it. And suddenly the whole thing came alive, and the feature that took 10 minutes to enable was the best part of the whole project, and it just brought it to life because you have these just wonderful little stories, and just going through it, you just read these little things, and you could just watch it and just sit there all day looking at really nice stories about seals and dolphins and porpoises. Cool. The other big aspect of this is that I learned was that the best successes on the web, like we always talk about new things, always talk about let's just use this new tech stack, new thing. Sometimes the best stuff is the most successful stuff is the stuff you put out there and you don't touch. Now, it is frustrating. I really wish I could go in, and they're trying to get some funding, so we're going to hopefully go in and try and make some edits here. But we have not touched this code since about 2013, and it just works. And it's ridiculous that people are using it all the time. Now, people talk about sustainability in web design and all sorts of things. What people don't talk about is the fact that sustainability also means not spending loads of development time, loads of hours that could be spent doing other stuff, and loads of energy, loads of resources on building new things. We should be building things that last for a long time. So something like the very first website built by Tim Berners-Lee, it still works. It's responsive because no one did annoying things with CSS back then. And it works, and it's a wonderful little thing that shows you how the web works. So don't be afraid to leave a project in a state where it can just maintain itself, and it just carries on. Of course, it is really nice to get maintenance to carry on things, but it's not always there, especially if you work with nonprofits. They might not have the opportunity to do it. So the next big project that we had, we were working with London Zoo, and there was a little idea. There was a new tiger exhibit, and we thought, so in the press team, we thought, wouldn't it be cool to say there are 300 Sumatran tigers left in the wild, and there are this many cats in London? So I thought, let's put a map together. I was really into Drupal at the time, so let's put some views together of sightings. Let's put a little node form for a sighting, and just put it out there. Do some little extra features like you can submit a photo of your cat, you can vote other people's cats up, the icons change color depending on what kind of cat it was, you can show a filter of how many tabby cats there are, all sorts of things. Now, it was meant to be London. It was meant to be, here's London, here's how many cats there are. So we launched this little project. Again, another thing is sometimes these things can take a long time, sometimes they can be just an idea and a quick thing. So we did this, put it out. What could possibly go wrong? It's basically like the seals. Now, unfortunately, it became a massive, massive viral hit. Basically, the only, I've had lots of successes, but this is the most, I think you probably get viral success once in your life. I was interviewed on the radio, Wired Japan did something about it. There were thousands and thousands of cat sightings. Drupal collapsed. It was basically not possible to do anything. The whole system had to be shut down in about 2 weeks because we were paying so much for server costs, and it was just ridiculous. So it was a really fun project, really nice, but definitely learned some lessons. It haunts me to this day. Often I talk to people and they're like, "Oh my gosh, you did the cat map," and it's just how it was. So people are also asking to rebuild it. I'm not sure I ever will, but maybe we'll approach the zoo and give it another go. But it was a wonderful project. But lessons learned from too many cats. So one lesson I always sort of tell my team this is always factor in scaling into everything. So whenever I hear someone in my team say things like, oh, this will work. It's like they won't do more than sort of 1,000 entries. There won't be this many things in the database. I always say, no, because we have to think about where things go as things go up. Of course, sometimes if you have a single import into a system and you know there's like 10,000 things, you don't have to think of a million. You don't have to think of so many users if you know this is small. But always factoring in scaling into a project is a really important thing, no matter what project you deal with. And you see this all the time. You see games launch and other things happen where you have a launch and it just collapses because too many people are using it, that sort of thing. So another lesson from this is caching is famously one of the hardest things to do. Drupal is amazing at this. The main problem, as you can probably see, is just you need to show the cat that someone added to the map, but also show all of the cats from the past. So it's like, how do you cache that? So at the time, I had no idea. I disabled views caching, had no idea what to do. Nowadays, I know how I would have done it, which is cache all of the old results and fake the fact that the new cat can be placed on the map and the one that people share can be on the map. But because that's only relevant to that user. They don't really care if someone in Taiwan has put in 20 cats since they last visited the website. They might eventually, but that you can do every hour. But what matters most is the data to that user. So having multiple caches going on. We use Redis a lot now for caching in the Drupal side. Another one is to think about client-side performance. So we did lots of HTML markers, and I don't know if you folks know about this, but HTML collapses if you have too many nodes. So there's just too much stuff going on. So you probably need to do clustering of any sort. I see this a lot on interactive maps that people launch for a project when someone's like, I will map all of this stuff, and then you see it grind to a halt because the fancy little HTML marker that they designed, suddenly you have hundreds of nodes. So using things like Canvas and clustering and that sort of stuff we're going to go into in a bit is the best way of doing that. So another thing to think about is doing everything out of the box in Drupal is not necessarily the best way. Now this is more of a lesson for Drupal 7 back in the day, or Starshot going forward probably, or Drupal CMS, because in the past you'll probably be horrified to know that at this time I was building pretty complex systems in Drupal and I wrote no PHP code. It was all rules, panels, views, the old-fashioned way of doing things, and then of course learned the other stuff later. So it's interesting seeing where the Drupal CMS stuff is going, because that just reminds me of old Drupal, the way it used to be. So but doing stuff with that is just it takes you to a certain level, but not necessarily all the level. The stuff Drupal is really good at is data structures. It's amazing at data structures. We do lots of complex databases. Data structures is like the best thing Drupal's good at. It's really good at REST APIs, so making JSON endpoints. You can use views for that, all sorts of things. It's really good at forms, but maybe storing and looking up really complex geospatial data is not where it is. Another aspect that I learned from this is that politics and that sort of thing matters a lot more than you think on projects that you think might not matter. Like a map of cats, that can't possibly be controversial, and yet it became really controversial because we used the United Nations official list of countries, and the United Nations official list of countries lists Taiwan as a province of China, and they hate that. And so we got so many complaints, and we ended up just amending it there. But it's this thing where you think, oh, this is uncontroversial. It means if you're doing something for a global audience, think about how the sort of worldview is there. Also, so I'm going to talk about this a bit later, but some mapping tools like Mapbox, which I'll cover, do really clever things, like they adjust country boundaries depending on which country you're viewing it from. So you can enable a setting to put disputed territories so that the person reading it from their territory sort of sees it. It sounds horrible to do that, but sometimes it's the right way to make sure that the thing can be viewed in the country of it being, the country is looked at. So what I was going to do next is just talk about some general sort of GIS, geospatial mapping features. Now, if there's any GIS experts in the room, I'm not super GIS expert. I do lots of web mapping, do occasional stuff in QGIS, which we'll talk about later, some Python stuff, all sorts of things, but I'm not like maps expert. But I just wanted to explain some core fundamentals around how mapping works. So the first thing is map projections. So we talked about politics and how things can affect different worldviews can affect things. Also talked about data visualizations lying to you when I talked about the seals earlier. So one interesting thing about maps is the world is obviously a sphere, a globe, and you need to project it onto a surface. Now, people talk about map projections. They are projecting like this, a globe onto a flat surface. That's what it is. That's where the term comes from. And you always mess something up because you're turning a 3D object into something that's 2D. So the one on the left, been used for hundreds of years. It fell out of favor because people were like, oh, this is a bit weird. And then suddenly the web came along and put it back into favor. So this is called Mercator or Web Mercator. You'll see it everywhere. And it's not very accurate because you can probably sort of see some skewing where you've got Greenland being giant. You've got sort of South and Central America being small. You've got Africa being like okay, but about the size of Europe. And you sort of don't realize things like most of North America fitting inside Africa, or just like how huge some of these things are and how absolutely tiny the United Kingdom, where I'm from, is and such. So unfortunately, this is both data visualization lying to you and the politics aspect. Of course, Central and Northern Europe looking big on a map sounds like maybe that was a good idea if that's where the maps were made from. And the areas that no one really cares about, the thing of like Africa being seen as a country by lots of people, and various other racist nonsense like that, is possibly stemmed from maps like this. So there are different ways of doing it, and you can do them on web maps. So this one's called the Equal Earth projection. What it does is it puts the things of the right size, but the angles between them are a bit funny in points, so it's not as good for navigation stuff and other things. And then the one at the bottom is a fairly new one called the orthograph a projection from Japan, and the person divided, I'm not a mathematician, but I think divided the world into triangles and sort of stitched it together. So, but looking at that, you're like, that doesn't look like the world, and you have to keep on thinking, I'm seeing a 2D representation of a globe. It's not, I'm not looking at the real thing. So just, think about these things. One really nice thing you can do is you can set projections live. So I'm going to talk about Mapbox in a bit, and there's tools, but other mapping libraries all have this sort of feature, or some of them have this feature, is you can just allow someone to have a drop down and see the world from a different perspective, see a globe when you zoom out, and other things. Cool. So other things I'm going to talk about is sort of longitude and latitude. So latitude going north and south, longitude east and west, and just these sort of grid lines that you can see. And this is a really useful system. It seems like, oh no, we've got all these crazy decimal points. You don't need all the decimal points. Go to a certain level of meter accuracy that you're interested in and look at that. So I don't get, well, no, I do get, as you can probably see from my t-shirt, I do get angry about tech quite often. But one of my most biggest sort of pet hates is this thing called what three words? Has anyone heard of what three words? So I hate what three words. I think it's the most nonsensical, stupid system there can be. It's like, let's get let's get longitude and latitude. Technology companies love doing this, which is like, let's get a problem that's been solved hundreds of years ago, sorted out. We know what it is. Everyone knows how it works. It's international, and let's make it English only. Let's make it proprietary, so we charge money for it. And let's make it just completely nonsensical in terms of working things out. So I'm from Greenwich, which is basically zero longitude. It's where longitude was invented. Well, it wasn't invented, but it was where John Harrison worked out a really nice way of calculating time very accurately, so they can work out longitude over long distance travel. So I'm at, I've got it written down here because I always forget, 0.001827 longitude. You can just say zero longitude. Doesn't really matter. That's fine. And 51 degrees latitude. Again, you probably need 0.48, something like this. Here, 2 degrees longitude, 41 degrees latitude. And you look at the map and you go, okay, it's minus 90 degrees at the bottom, plus 90 degrees at the top, 180 degrees to minus 180 degrees in the middle, and you can generally work it out. And so looking at something, if someone gives a longitude, latitude, you can go, okay, I roughly know where this is. If you're looking at the idea of like 0, that's this thing called Null Island, which is famously sort of off the coast of Africa, which this is a funny thing when you build maps, if your longitude, latitudes are wrong, everything gets dumped in Null Island. There's actually a buoy floating at Null Island with a little marker on it that some scientists put there, but it's 0. But if you look at what 3 words, I won't rant about it a whole lecture, but what 3 words for this place is snaps, sprays, soccer. Now, what nonsense is that? Like, why would that be helpful? You can't go, how much north of Barcelona city centre is snaps, sprays, soccer? Like, how is that in a different language? When you're like, we talk about it being really useful for pinpointing locations on a map for emergency services. That's like one of their big things. And people are starting to use it. But emergency services are getting confused because certain words sound the same when garbled over a phone. Numbers, pretty clear. Every language, pretty clear what they're saying. So don't use what 3 words. It's awful. Cool. So there are some really fun things in terms of longitude, latitude to deal with. The main one that is sometimes problematic is the anti-meridian, which is the sort of line that goes down the middle of the longitude, where things basically wrap around from one day to another. Now, usually it's placed in a place that sort of no one is. There's a few islands there, but it's generally placed out of the way. So you don't usually have to deal with lines crossing it. So this brings us to the next lesson, which is that real data will do everything it can to test you and destroy your plans. So you have this really nice idea of what to do about maps, and then you do something like this, which is the seabird tracking database we built. And as Chris from my team will know over there's lots of birds that cross the anti-meridian line, and you map them, and then suddenly you have this weird line that goes across the world, and it's a bit of a mess. However, I'm going to talk about this in a bit, is all these problems have been solved for you. So all the mathematics has generally been solved. The easiest way of doing it, you split the line. So when it gets to minus 100, and when the next point is more than sort of 360 degrees from the previous point, I think I've got that right, I'm awful at maths, then you basically add 360 degrees to it. So, or you just split the line and then just carry on afterwards. So you have these 2 lines. It's solved. You can just look this up. How do I deal with the anti-meridian line? And it's solved. So that is a common thing. So moving on. So what can you show on a map? So here are some things that you can show on a map. We've got points, we've got polygons filled with patterns, maybe. Got bounding boxes, which is just like, you have a lot of bounding box stuff when you're dealing with sort of how to set a map in sort of on a page, like where to zoom to, which area, check if something is in a bounding box. So that's generally like top left, bottom right, or top right, bottom left coordinates. You've got lines, you can animate lines, you've got 3D buildings and 3D models that you can put on, sort of raster data, which is like sort of pixels, like color-coded pixels, depending on where there is. Photos, videos, there's an amazing example of a video of a beach with waves going on it that's on the Mapbox website, and I'd love to use video, but I've never found an opportunity to actually use video overlaid on a map. It is possible. You can show movement data. Now, curves can't really show. None of the specs really handle curves, but what is a curve but a series of points? So just do a lot of points along the map. It's fine. You can do heat maps, which are kind of raster data, kind of not. Some libraries support them by calculating them directly. Mapbox is one of them. Other things also do heat maps quite well. Elevation, bathymetry, that's up and down. So we do some bathymetric mapping. Actually, I've got an example I'll try to show later of sort of bathymetric lines of depth that we used for divers for a project where people could tag angel sharks, which is a species of shark that lives in the Canary Islands. And then elevation data sort of up and down. You can also show sort of 3D terrain on most of these systems, which is really nice and actually really useful for some of our projects where you can sort of see mountains and see how things go. So there's a lot of things that you can show. That's pretty much it. Now, Then we have ways of storing data. So this is where it gets kind of scary. So you've got CSVs. This is comma-separated value spreadsheets of longitude, latitude, that sort of thing. We often use Google Sheets as a CMS of sort, where you use the Google Sheets API to sort of read into a system. GeoJSON, which is my favorite standard of that, is a way of, so JSON is a data storage in string system that you folks will hopefully know about, and GeoJSON is a way of using that to show polygons, points, all sorts of things. You've got shapefiles. They're the bit that there's a company called Esri who do lots of mapping stuff. They have a product called Arc, and they have a format that they invented called shapefiles. It's the most annoyingly named format because it's not a file, it's multiple files. So the SHUP file as part of it is one of them, but there's actually 13 file extensions in a zip file doing things. Some important ones might be missing from the ones that you've got, so just checking what you've got. So you've got KML, which Google used. You've got well-known text over here, which is basically spilling out a polygon like that. Do I have a cursor? No, I don't. But you've got geotiffs, which is a TIFF, which is an image file with data saying where certain things are, and that each color has a value. You've got a geodatabase. You've got MB tiles, which is Mapbox's tiling system, where you've got PNG tiles, which have data on them. You've got ZXY tiles of other sorts. Z is sort of top, the zoom level, X and Y is the coordinates. You've got MySQL geometry types, MongoDB, PostGIS, which is Postgres' version of geospatial stuff, SQLite. It's terrible. It's like so much stuff. Now, so don't have to learn all this. The main thing that you need to learn is that there are two types of data. One is vector and one is raster. That's it. So you have vector data, which is points, polygons, that sort of thing, and raster data, which is like Google Satellite, or sometimes data where each thing is colored in a different way. And if you've got a raster layer, which is not that complex, it just generally has sort of pixel outlines of things, you can use a tool, QGIS, which I'll go over in a bit, to transform one into the other. It basically traces. And as we all know from computer science generally, computers are really good at doing things that would take a human a long time, and it just traces the outline and turns it into a series of polygons. Don't obviously do that on Google Satellite or Mapbox Satellite or anything, because it would just be nonsense. Just have millions of polygons, and your computer will crash. There's a lot of crashing computers when you're dealing with geospatial data, because the files are sometimes very, very big. So transforming data. So I will actually get onto some pretty pictures of maps in a bit. But the first thing you need to do is, what are you trying to get to? What is the data? What do you have, and what are you trying to turn it into? Always think about that. Make lots of little scripts. So I write a lot of little Python scripts, little JavaScript scripts that do something like take a file, add some attributes, do something like that to it, merge things together, that sort of thing. But understanding the data that you're dealing with is the main thing. I put a little comment about don't throw away your scripts. I have a tendency, as my team will know, of writing code and then deleting it because I don't need that anymore. So don't do that. Store them somewhere, because it might come back to them. I'm going to mention that in a bit as well. So thousands of years of human history have worked out the maths. So generally every bit of maths that you need to do to work out the intersection of this and that sort of thing has been done for you. You don't need to worry about that. That's generally the thing you need to know about is it possible to work out how many points are in this? Yes, it is. That sort of stuff. So think about what you need to do. And generally, if you know the right words, like sort of intersection and polygons and points and that sort of thing, raster, vector, you can usually work out just doing a few searches. Mixing languages. So don't be afraid to use Python in a Drupal project or a JavaScript in a Python project. It doesn't matter. You can just use the best language for the best thing. It's something that I always felt ashamed of, and then I saw some conference talks here and other places where people do it, and it's fine. Just do it. The best tools for the job are the ones you should be using. So computing is mostly dealing with lots of lists. There's lots of sort of JSON manipulation and stuff to do. So what I'd recommend you do is, if you're doing programming on this side, is just learn how lists work. Do lots and lots of list stuff. So work out how to fold, map, filter, sort, reduce lists. The way I taught myself is I learned some Haskell. So Haskell is one of the most weird and wonderful programming languages. It's not that useful in the real world, but it's inspired all the other functional programming languages. And learning Haskell, there's this amazing book called Learn Your Haskell for Great Good that is available free on the web, but I've got a physical copy because I like books. But it's a wonderful book that even if you just read a few chapters of that, your programming in every language will suddenly level up hugely. It's wonderful. And it's got some silly jokes about Avril Lavigne and things in there. While you're doing this data, annotate the objects that you're dealing with, the data, with as much useful information to look things up quickly as possible. So don't worry about duplicating data. Objects are passed by reference, so you can have lots of things referring to the same objects and build sort of lookup indexes of things. Don't be afraid to use different programming languages. You can also compile down to executable files, so you can run Python and JavaScript without having those installed on a machine. There's lots of tools to compile them down to files that you can just run from Drupal. We do this a lot. So another thing we do, and I'll show, I would like to show an example in a bit, is use easy to manage sort of JSON and configuration files or Drupal as a CMS, where sort of like structure and management of data, not just for you, but for the client eventually. So Drupal's really good at this. JSON YAML is really good at this, sort of for laying out how layers sit. I'm just going to quickly just show an example of that because that's one I forgot to do. Let's just show this example. So here is a JSON file that just shows sort of which terrains, which things I'm using. This is like the XYZ thing, which tells you like, get me a PNG of this X coordinate, this Y coordinate, and this Z. The zoom level for this thing from Google. And here are the layer sets with colors, opacities, that sort of thing. So having a configuration file like this, even if you think you're never going to use it, really, really useful. Always do that. So from current slide, okay. It's reset my timer. So organize your files in a sensible structure, naming system, or you'll forget what's been done to them. So say processed, minimized, cut down, this has this properties, that sort of thing. I never do this. I need to do this better. So that's why I've got actually listen to your own advice. The last one is don't throw away stepping stones you've got on the way to data. So if you're doing some processing to make something smaller, don't throw away the big one or the one in the middle, because you might mess up the last step and then you have to do everything again. So that's a really important lesson to learn. Okay, so tools to transform and prepare geospatial data with. So I'm going to go through some of these, which is some tools that you can use. So if you want to take a screenshot or something of this, these are just really nice ones that I use a lot. So QGIS, ArcGIS is the sort of expensive version, but QGIS is an open source, wonderful system which basically can do any sort of geoprocessing stuff. As with many open source projects, the menus are like, it's very lots of menu diving, looking through things, that sort of thing. It's also some really helpful things are in really weird places. So I'll just show QGIS now. So I've got let's just see if I can, there we go. So you load in a layer, and this has all sorts of tools for doing things. But if you look here, you've got things like simplifying or repair. So generally there's repair here, repair shape files, that sort of thing. Look at, you can just do lots of things. Merging data, simplifying data, that sort of thing. It's a really useful tool for that. What else have I got? So there's some behind the scenes. This uses lots of Python libraries. You can install a thing called GDAL, which is a lots of geospatial libraries. It's the most annoying installation process I've ever seen. It makes you install basically virtual machines and all sorts of things to make it work. I have a nightmare doing it, but I've got it installed on my machines. I sometimes use it, usually just use QGIS or other things to do things. But you can, there's lots of Python libraries to do things really, really quickly, like merging data, working out things like that. Cool. Then What else have I got? So I'm going to go straight to MapShaper. So MapShaper is one of my favorite tools. It's if I just go to mapshaper.org. So this is a really nice tool where you can generally drop any sort of vector data, so shapefiles, GeoJSON, anything like that, and it just loads it in the browser. And here's some data. I've just dropped it in. Zooming badly, it shows you sort of properties. If you click on something, it shows you what the properties are, and you can put base maps on. You can simplify things. So there's a simplification algorithm. So you just go like this and simplify data, and you can export. You can change the projection, do all sorts of things. It's a wonderful tool. It's just out there in the browser. It's free. You often don't need QGIS. You can just use this. So that's a really useful tool. There's what else am I going to go through? So there's a library called Tippecanoe. I'm sorry if I've pronounced that wrong. It's an area in the United States that is used for making what are known as vector tiles. So you've got some GeoJSON data that's huge, multiple gigabytes, and you want to upload it to a service like Mapbox or MapTiler or something like that, so you can serve the tiles quicker. Because you probably notice when you look at a map that it does it in tiles, so it does things gradually as things go. So that turns things. It's a command line application, really easy to use. The documentation is really good, so I thoroughly recommend that. Rasterio is the thing to do for raster files. So if you want to do things like recolor them or do other things. I mentioned MapShaper. Turf.js and GeoPHP can do pretty similar things than that. But Turf.js is one of my favorite libraries. We use quite a lot for other things. So Turf.js is here. Again, I will not go through everything on it, but all the things about intersections and working out polygons, working out like merging things, working out the center of something, the area of something, it's all been done for you. It's mostly in this library. You can run it directly in a browser. You can run it offline with Node.js scripts. It's a wonderful thing. Got really good documentation. Generally takes in GeoJSON, spills out GeoJSON. Cool. So moving on. So I said your own Node.js sort of Python scripts. So hosting maps, we've got things like you can host inline JSON and image files. You need to look at how big those are, because it's quite easy to accidentally pop in a multiple gigabyte JSON file and expect browsers to use it. You can self-serve things using a tile server, or Mapbox does this for you. MapTiler does this for you, where you can just upload tiles. If you do use tile server PHP, I put a little note: be careful of maximum open files. We were hit by this recently. PHP has a sort of limit of how many open files it can have, and we hit that. It's just a server thing that I put there. There's other things to host tiles. You can use Mapbox, which is a really nice service where their free limits are really high, so generally you will never be charged for their services. PostGIS is a Postgres database that has geospatial stuff for it. Drupal has a wonderful geofield which can be used as PostGIS, so it stores geospatial data. You can use views and other things to look things in. A static map, so what Mapbox lets you do is have a static map where you can just have like where we are, and you don't just get it as an image. So you pass in various parameters, you get a marker and an image, and you just get it as an image. So you can just save it somewhere and just host it on your website. We do a lot of hosting on GitHub pages, where we have little GitHub actions to compile like the JavaScript and CSS when things change. And that just because GitHub pages is basically free hosting, and you can just have static sites there. So right, here is where I will run through again. If you want to take shots of this, I'll try and cover as much as possible here. But the stuff you can do on maps is you can do ridiculous things on maps. Everything you can possibly do. So looking through here, locate user, live track them, recolor, typeset a map. Mapbox Studio, which I'll probably not have time to show, has a really nice interface where you can recolor like all the streets, all the things to be a certain way. You've got layers, groups, draw things onto maps, custom controls, all sorts of other things. You can do so much. Now I put at the bottom again, too many options. It's true, there are loads of options, but What should you do is make sure the data makes sense first, make sure you understand the data, work out which story you're trying to tell, and maybe play with some other data visualization. So data tables, JS is a wonderful table library that does sorts and filters. Charts, we use D3 a lot. So D3 is like data visualization library. It's basically a calculation library that works out if I've got this start and this end, where would this sit on as a point, and you can draw your own charts with it. It's beautiful. It's like an SVG or Canvas and like library to do that sort of stuff, and find the simplest way of telling that story. Very often, just a few polygons, markers, and pop-ups is usually enough of what you need. So I am going to just show some little examples of things that we've done, and then hopefully have like 3 minutes for questions. So there's the seal map. As you can see, we've got some pop-ups that go up. We've got this, which is a map of sort of species habitats and sort of climate change data, other things, loads of things like that. What we did here is we built a way of using a sort of dynamic paragraph to work out what you're looking at. So it goes to basically show something like that. With raster data, this is raster data. It's basically pixels showing certain values at certain points. This needs to be raster. We've got a D3 chart here showing information, legends and that sort of thing, changing opacity sliders. Here, this is a Drupal site. We've got linked directly to views. So this is a views attachment, if my internet works. Come on, internet. So this is just a view. You've probably seen views before as you're here, and this view filters both this map and various layers within it, but also shows things as a list. So we do toggles like this where we do an attachment of coordinates and things on the view, and then or use the views REST API thing to do a JSON feed, and in parallel, so the exposed filters talk to the attachment. They run in parallel. We've done exactly the same thing here, where we've got a list of organizations for a conservation technology sort of wiki that we built, and we've just got a map which does the same thing, so you can search and filter. I've got one of my points on that previous slide was put ridiculous things in pop-ups, and show things at different loom zoom levels. So your pop-ups can have sort of live data and templates in them. So don't be afraid to call a template and put stuff into it. Also, you can show different data on different zoom levels. So this is arts demographics for one of our arts projects. Really nice sort of data visualizations on that. We've got, this is the config file I showed you before. This is what it generates if they want to add a new layer. We've got this if they want the layer to have its own opacity slider. You can do that. We also put some custom controls here. So Ronan and my team did some really nice things where you can, we reordered these icons a bit, and Mapbox lets you add like controls to the top right, top left, that sort of thing. We did some really nice hovers here. If I just accept here, in the bottom left, you can see the elevation data. So this is just straight. Mapbox supports this out of the box. Other libraries do as well, and it just queries the raster pixels for that area to work out what the elevation is. It's really just, I could just look at it all day, just work out how tall things are. Cool. This is another one where this is seabird tracking database. It's again a view storing information in a Postgres database with geofields and things. So if I click on this, we're going to have a map. So yeah, it's just birds are fun. So got that. One of the other things I was going to show is maps don't have to be real information. So this is a historic timeline of London Zoo with a little thing where you can go to different points and such. But these maps aren't geographically accurate, so we worked out the GPS points from on a fake map. So you can use that. You can use that to do that sort of thing. Here is a map of sustainable seafood in the UK. This I show as an example of again, PHP, MySQL doing all this stuff, but look, you can use Mapbox Studio for free to just color a map and make it look exactly as you want it. We did the same thing here, which is mapping coral reefs in the Chagos archipelago. This is mostly underwater, so we did some hovers to show sort of what the things are, but it's a map unlike anything you've seen, but it's all done in Mapbox Studio. What else have we got? This is another Drupal website, which is again views. It's for the National Red List project, and it's just lots of views and searches on that information. We've got this again showing this is again a nice simple thing which shows some nice pop-ups. What we did here is animate the markers so you can see a little preview of the thing inside it. What else am I going to do? I think that's those are some demos. So moving back to my slides. This was added yesterday. Is what should we do is, after looking at the recipes things, I think maybe we're going to put together some Drupal recipes for if someone works on those things and wants to come and chat to me and collaborate. I'd love to do that. And thank you very much. Yeah, we've got some bonus tips here. As I said at the start, please stop working for bad companies, building tech that makes the world worse. There's loads of work in the non-profits, conservation technology, various other things. Trust humans and experts over technology. There's lots of great scientists working with data. Don't trust your AI algorithms, trust them. And we're recruiting at the moment for a developer. So if anyone wants to work with us, please get in touch. Thank you.
So thanks for that. One of the challenges is that between Drupal and all the mapping stuff, there's just so many approaches. I'll often be asked, oh, we want to show a map on Drupal. How should we do it? And it's like, well, you could do it this way, you could do it this way, you could do it this way, you could do it this way. Usually it's kind of, use Leaflet or D3 kind of as a bridge. And I don't know, that's kind of where I'm at with my best practice recommendations. I don't know if you have any other.
Yeah, so I would say the best practice is keep the maps away from Drupal and store the data in Drupal, use Drupal for management of the things, and then make a REST API of JSON points, and then you can chop and change. As we all know, JavaScript frameworks constantly change, maps will constantly change. If you have a feed of points that's in GeoJSON, that can be read by a front end, that's sort of basically headless and stored inside your Drupal site. I think that's generally the best way. You can do it as an abuse attachment, as we talked about, but making sure the data comes out in GeoJSON format, so Leaflet can do it, other things can do it, OpenLayers can do it, everything. I think that's the best way. I think Leaflet is a wonderful, wonderful library. We use Mapbox for most things, but Leaflet, the main developer for Leaflet now works for Mapbox, but Leaflet is the most user-friendly API there is. It's just amazing, and for most maps you'll be doing, it's fine. Mapbox GL is a bit faster, and does a bit of complex stuff that you might need, but Leaflet is brilliant for that sort of thing. But yeah, I think get it out in GeoJSON format is the best tip that I have, and then you do a headless front end that's separate, because then you can change it if needed. Cool. Does that help? Cool. No questions. Feel free to ask me anything at any point, or even if you've got some maps and you just want me to look at them today, I'm happy to do that. Free consultancy time. Cool. Thanks, everyone. Thank you.